Hi, Mr. Eslop here. I'm going to show you how we find averages and draw graphs that you might not have drawn before on Excel for discrete data. So here I've got some discrete data that's from one of my favourite topics, Blackburn Rovers Football Club. I have over the last 23 seasons the amount of goals scored each league season and the amount of points they gained each league season. I've set up a little table here to find the mean, median, mode and standard deviation for goals scored and points gained. And that's quite easy to do on Excel. To find the mean, what we do is put equals, because right in the formula, and it's just average. I can click on it once it starts to come up. And all we have to do now is select the data that we want to find an average of. And that's all this. You want to find the mean of all this data. And there we go, it's done it for us. It's found the mean of that set of data. Similarly, for points gained equals average. This time we find the mean of all this data. Just drag it all down. And there you go, that is the mean number of points gained. Median, just as simple. This time you put equals median. And again, just select all the data. Close the brackets. And the median number of goals scored is 52. Points gained. Then it's all this data, find the median of. And that's 58. The mode, you have a bit of thinking to do. We start putting equals mode, a few different things come up. What we want is this one, mode single. So it's a single set of data looking at, not multiple sets of data. So mode single. All this, and this will find us the mode goals scored. 51. Similarly, points gained, mode single. We're looking at this data, the mode points gained. That's 58. Standard deviation, same starting point. You put equals S. So start writing ST, and then what we want is this one, ST dev P. Standard deviation of the entire population. We don't just want the sum of it, we want the standard deviation of all this data. So we want that. Standard deviation P, SDev P. Again, select all this, and that tells the standard deviation goals scored, 11.7. Of points gained, again, SDev P. Standard deviation points gained was 16.1 for three significant figures. Well, that tells us that the points gained is varied more about the mean than the goals scored. Now that was fairly quick, but actually what's probably quicker, and some of you might prefer to do if you're in school where we have autograph, is you can find all that information and more on autograph. I'm going to open up autograph. I've already given you a worksheet showing you how to do histograms and cumulative frequency graphs and box plots on autograph, because autograph is much better than Excel for group data and continuous data. But it can also be used for discrete data like this. Let's go to standard mode. Whenever you're doing anything in statistics, you want to click this thing here to say I want a 1D statistics page, and it gives us the right format, frequency on the y-axis, if we want to say start drawing graphs. I don't actually care about drawing graphs, I just care about finding some statistics, averages. And so what I do is I click here enter raw data, because it's not group data, it's raw data. And I'm just going to find all my averages for my goals scored. I'm going to copy and paste all my data for goals scored from here into there. Let's call that raw data 1. So now just right click on that and click view statistics box. There we have it. We have all the averages we need. We have a number in the sample, which I can call n, 23. The mean, 53.6522, which agrees with what it says here. And the standard deviation and the median also agree. One thing we are lacking is a mode, so that was one useful thing about Excel, the fact they gave us the mode. Another thing just to bear in mind if you are finding your data from autograph. It's very good. It also finds you the range, lower quartiles, upper quartiles, all just in one click of a button. But this thing down here is a semi-interquartile range. Don't mistake that for interquartile range. What that is half the interquartile range. The interquartile range in this case is actually 15. And you could also have obviously seen that by doing upper quartile 61 minus lower quartile 46. And we could have done a very similar thing with the points gained. Again, go enter raw data. View, that's called raw data 2. View, right click on that, view statistics box. And again, I've got all the statistics, which again do agree with what we got on Excel. So that's finding averages. What I also want to look at here is to see if there's any correlation between goals scored and points gained. I'm guessing there will be a correlation, because if you're scoring lots of goals, you should be winning lots of games, should be gaining lots of points. Obviously, the best graph to draw to see if there is a link or relationship or correlation is a scatter graph. So I'm going to draw a scatter graph of goals scored against points gained. And to do that, I simply just highlight both columns. And I go Insert, Scatter. I don't want to join up the points. We never join up the points on scatter graphs. We want to see all individual points and draw a line of best fit through them if the line of best fit is applicable. But we need to see if line of best fit is applicable first. So always go for this one here. And there we go. It gives us a scatter graph like that. It's plotted all the points for us, which is nice. A few things you have to do to make it acceptable though. First of all, we don't need the key or the legend as Excel calls it. So we can click on that and then select delete. The title shouldn't really be points gained. It's more points gained versus goals scored, you could say. And then now it never automatically labels the y-axis and the x-axis. We have to do that ourselves. You might think here, I can't tell which one's which because they both involve similar numbers. What Excel will automatically do always is the left column will always be the x-axis and the right hand column will always be the y-axis, and we can just self-check that sort of thing. We've got here a value that's hovering. It actually mentions what that point is. It's 76.91, and when we 91 you can see is on the y-axis. And we actually find that 91 was a points gained, 76 was a goal scored, so we can self-check like that. To label the axes and to do a lot of things with graphs. If you ever want to edit your graph, select on the whole graph, and it's a layout tab is where you do a lot of the things you need to do. If I go layout tab, I can add grid lines and all sorts, which can make it look easy if you've got squares instead of just lines across. But all I want to do now is just change the axis title. So I'll say axis title, horizontal axis title, I want that below the axis, and we know that's goals scored. And then the vertical axis, rotated title is the best way to have it. So it looks like that, it's rotated down like that. That is points gained. So there we go, we've got a perfect scatter graph with both axes labelled. Because we can see there's a correlation, I think it makes sense to draw a line of best fit coming through like this. But we're not just going to go to the drawing tool and do that by eye. Excel will draw a line of best fit for us. Select on the graph. Again, on the layout tab, you go to trend line. And it gives you loads of trend line options, and we can actually see even more if you click on more trend line options. And it says it gives us the option to do different shaped graphs, different shaped lines of best fit. We can see here a straight line seems to fit the best, so we're going to keep it at linear. So as we know, it's also very useful to find the equation of a line of best fit. Then we can make predictions, interpolate and extrapolate, etc. And that, Excel will do that for you. If you just tick display equation on chart, I've got my linear line of best fit. There we have the line of best fit and the equation of it. I'll just move it so we can see it better. You might want to put it wherever you want. There we have, that is the equation of our line of best fit, and that is our line of best fit. So now that I can see there's a correlation, I want to be able to say just how strong that correlation is, be able to put a number to that correlation. As we know, the way of doing that is Spearman's rank correlation coefficient. Unfortunately, Excel will not just let us highlight both of these and quickly find Spearman's rank. It doesn't have a function for that at the moment. So we've actually got to do a bit of work ourselves. Excel will still do a lot of the hard work for us, but I've added some columns to this table to help Excel help me work it out. First of all, I want to rank the goals in order. And again, I don't have to do that by hand, because that can be quite hard if there's lots of sets of data. Excel will do that for me. The function used there is a rank function. Put equals rank, and the first thing it wants to put in is number, and that means what number do you want to be given a rank to. And in this box here, where I'm ranking the goals, I want to be given a rank to this number. So I put a comma. Now it's ref, stands for reference. I want you to say, what do you want to rank it against? I want to rank it against all these. All this set of data, I want to say what order that comes in. And now that's one thing that we've got to stop and pause for a minute here and think, is we're going to eventually end up scrolling this formula down through all these cells. And Excel's quite clever. It will automatically, as we scroll it down, change that blue number to B3 in this box, which we want it to be doing. B4 when we're here, good. B5 when we're here, good. What it will also do is it will make these numbers go up one every time. And we don't want that. Every single time when we're ranking any of these numbers, we want to be ranking it in the set of data between B2 and B24. So, in order to make sure these numbers never change, whilst I'm in it, I've just written it. If I type F4, then it does that. It makes it the absolute values. That means as we scroll down, it's always going to rank the numbers against B2 to B24 data sets. And it's not going to change those, and that's what we like. And I put another comma, and the order, as it says, if you put a 0, that means you put in descending order. A 1 means you're putting in ascending order. Doesn't matter which one of those you do, because we know all we care about is the difference. So as long as you're consistent between goals rank and points rank, you can go with descending or ascending. I'm going to go descending. That's told us that 51 goals scored, which is ranked 13th. If I now scroll it down, we can see that just like I said, this one here, this number's gone up to B3, like we want it to, but these two numbers have stayed as B2 and B24 because we put the dollar signs in. Same here, B4, but still B2, B24. And we can do a little self-check. Number 1, it says the most goals scored was 80. Yeah, that looks right. And at number 23, it says the fewest goals scored was 32. Yeah, that looks right. The points rank, we do the similar thing, but just looking at a different column. So this time, when we're looking at this number, when they be compared to all this column, I'm going to press F4 now to make sure those three numbers don't change. And for consistency, this has to be in descending order because the goals rank was. Again, 13 points rank as well. There we go. Scroll that down, and we've ranked them in order. Number D stands for difference. To do difference, I'm just going to simply do this number minus this number. And scroll that down, it'll always do those two numbers minus each other. And I've got all the differences. And now I just want to square them. To square them, just put equals this. And use a little number above the 6, little thing above the hat above the 6. And that will square that number. If I scroll that down, it will always square the numbers next to it. So that does F3 squared, F4 squared, etc. And you can check they're the right numbers. Minus 2 squared is 4. 7 squared is 49, etc. So there we go. That was quite easy. Excel's got all that data for us. What obviously we know the Spearman's rank correlation coefficient formula involves though is adding together all the d squareds, finding sigma d squared. So when I've done little things here, they prompt me in my working out. So sum of d squared, sigma d squared, we need just some function. I just want to add together all these. That is sigma d squared, adding together all of these. And if you remember, the numerator of the fraction in the formula is actually 6 multiplied by sigma d squared. So actually what I want to do is multiply, and for multiply I use the asterisk. multiply this number by 6. N, we already know, is 23, the number of values. And to do, remember the numerator of the fraction is n multiplied by n squared minus 1. I'm going to write that is going to be that number multiplied by, don't forget your asterisk, multiplied by that number squared minus 1. And then if you remember, the bit of the fraction on Spearman's rank is 6 sigma d squared divided by n multiplied by n squared minus 1. That means that is that number, put a forward slash for division, divided by that number. And just to finish it off, remember you do 1 minus that fraction to get Spearman's rank. And there we go, Spearman's rank correlation coefficient is 0.863, or 864 to 3 decimal places, which, as I suspected, shows it has a strong positive correlation. So another thing you might want to do with this data is do things like a time series graph, because it's data given over time, so time series graphs make sense, or find moving averages and look at trends, etc. So I'm going to, for a time series graph, say I want to look at the trend of goals scored over time. I would highlight both the year and the goals scored. This is where you would automatically do the wrong thing, because the natural thing to do here is to go insert line graph. What a line graph would do is it looks at the year as one data set and the goal scored another data set, and automatically puts just 1, 2, 3, 4, etc. on the x-axis. So you'd end up having 2 lines, one of them being the year, one of them being goal scored. We don't want that. We want the year to actually be the x-axis, goal scored to be the y-axis, and just one single line, not 2 lines. So what the data is. So to do that, even though this is against what you know, that Excel gives things weird names, you actually go scatter. And you want this one here where it shows the points and joins them up with straight lines. As you can see, we've now got time on the x-axis that I wanted, goals scored on the y-axis. And again, I'll make the title goals scored over time. To change any axis crossings, any axis labeling, sorry, go to layout. I'll call that one yeah. And this one, goals scored. That's quite good. We've got our time series graph there, but obviously it's quite good using time series to look at trends, and we can plot moving averages to find trends, and that enables us to find a trend line. That's the Excel finds a trend line for us without us plotting the moving averages. And again, a linear trend line. I want to see the equation of the trend line. There we go. That's showing the general trend is it's going down the amount of goals scored over time. And the equation is that. That's a time series with a trend line. What you might also want to do is have have goals scored and points gained, 2 separate lines on the same time series graph. You'll often see that with time series graphs. Comparing data. To do that, we highlight all 3 columns. And again, just go to the same scatter graph. And there we go, we've got it. And in this case, we need to keep the key, or the legend as Excel calls it. So that makes sense. That tells us which one's goals scored and which one's points. And again, we can just change the labels. So that one is year again. That one, it's not goals, it's goals scored and points gained represent, so I'll call it maybe amount, because it's something that you can't put either goals scored or points against, or points gained, sorry, because it represents both of them in the y-axis. I'll just add a title as well. above the chart, comparison of goals scored against points gained. So there we go, got my time series graphs. A bit of a clutter when you try and compare them like that. You might need to graph too bigger to see what's going on. I've got it for just goals scored over time with my trend line and the equation, and I've also got it with them both on the same graph. You may also obviously want to find moving averages. There's not a massive reason for me to find moving averages in this case because I get a trend line anyway done, so that's one of the main points of moving averages to look at trends, and there's no, I don't have data by seasons or anything like that, but as in terms of seasons in July, in terms of spring, summer, etc. But I'll decide to do a 3-point moving average anyway, just because the average amount of time before last season that Blackburn manager stayed in charge over the last 23 years, it was 3 years. So that's sort of an average per manager, so to speak, if we keep going through 3-year cycles, because the manager's changing every 3 years. So I'm going to do a 3-point moving average, and that's quite easy to do. But remember, it's just a mean. So remember from earlier, that is average. And the first 3-point moving average well, I'll do it for points gain, 3-point moving average. It's going to be those three. I'll change the title, 3-point moving average, points gain. That's the first 3 bits of data. What I've actually done wrong there, so I'll rectify there, is obviously the first 3-point moving average should be plotted in the middle of the 3 sets of data, which is in line with the second set of data. So that is where I'd want that moving average to be. And then now, I'm going to scroll that down, and that has automatically found then the next one, it's found in the middle of these 3. Then this one's found in the middle of these 3. This one's found in the middle of these 3. Well, found the average of those 3, sorry, etc., etc. So I've got all moving averages, and if I wanted to, I could plot them as well on maybe a separate scatter graph. Those 2 columns, year and 3-point moving average, scatter, and there we go, 3-point moving average, points gained. Again, don't need the key. Again, this can be points gained over time. Moving average of points gained over time. And then I can change the title again to year. And points gained. Oh. And there we go. So I've done a time series graph with just goals scored onto the trend line. Compare the 2 time series graphs, goals scored and points gained. Then I've done a 3-point moving average of points gained over time. I'll write that on, 3 points. And again, on this graph, I can put a trend line on it. And what I forgot to do there is I can obviously find the equation of that trend line. And just like goals scored, points gained is also been going down a little bit over time. So there we go. Hope you found that useful and can use it in the collecting data part of your controlled assessment.